till now whatever we have studied is what happens when light undergoes refraction and dispersion and scattering. Now we'll do the same thing, but what we are doing is application of those. So when we say application, it's basically for optical instruments. So first thing what you will be learning is a microscope. Under that, we have simple microscope and compound microscope. So first let's start with simple microscope. Now what we have is, so we have a lens. So once we have a lens, obviously we need to have a center for the lens. So for that, what we'll consider is, so a principal axis. So we have a principal axis. So the center of the lens, let's call it as C, and let's say F be the principal focus. Now the object what we are keeping should be between the principal focus and the center of the lens. Now why it has to be in between, you will get to know just soon enough. So what we are doing is we are keeping an object, let's say here. Let's call this as AB. Now AB is the object, F is the principal focus, C is the center of the lens. Okay, now what we have is the ray of light will pass. So one ray of light will pass like this, and this particular ray of light undergoes refraction. So it goes something like this. Next, one more ray of light. This particular ray of light goes undeviated, meaning it is passing through the center of the lens. So what we have is, see, we have two rays of light which are going like this. Now, since the object is between the center of the lens and the principal focus, it forms a virtual image. So what happens is, it goes, one ray of light will go like this if we extend, and another ray of light, if you trace it back, so another ray of light will pass through like this. So we might have to extend this ray of light also a little bit. So what we have is, so the both of the rays of light, they'll meet at this particular point. So now what we have is, so we have the object which will be formed at this point. So what we have is, the image will be formed here, so which is A dash and B dash. So this is how an image will be formed in a simple microscope. All right. Now what we are looking at is, we are looking at the magnification produced by a simple microscope, right? Now see, you have AB here. Now with the same height as AB, we draw another point here somewhere here. So let's call this particular point as Q. So what we have here is QB dash is equal to AB. So what we are looking at is, we are comparing the height. All right. Now why we need that particular Q, point Q, is, suppose let's say we join from the center of curvature or the center of the lens to this particular point Q. See here, this point. So we'll join this. Now what we'll name is, we'll name this angle as alpha. That is, we have angle QCB dash as angle alpha. and this whole angle as beta. So again I'll repeat, we have QCB dash angle as alpha and ACB as beta. So this is what we have. Now when we talk about the magnification produced, see, when we talk about magnification produced, so it's nothing but the ratio of the angles beta to alpha. Okay, I repeat again, we have the magnification as beta to alpha because beta is the angle subtended by the whole length a dash b dash, correct? And alpha is the angle which has been produced by QCB dash, which is nothing but the length of the object, right? So the size of the image to the size of the object is the magnification produced, which is nothing but beta by alpha. Now, since beta and alpha are very small angles, we can write beta is almost equal to tan beta and alpha is almost equal to tan of alpha. So we'll use this particular condition. So we have m is equal to tan beta by tan alpha. Alright, so tan beta by tan alpha. So now what we'll consider is we'll consider two triangles. Alright, so in triangle QCB dash, QCB dash. So in this we'll consider tan of alpha. So tan of alpha is QB dash by CB dash, QB dash by CB dash. Now QB dash is the same as AB, so we can also write this as AB divided by CB dash. So we got tan of alpha. Now we'll consider triangle ACB. In this we'll consider tan of beta. So tan beta will be nothing but AB divided by CB. Alright, now what is magnification? Tan of beta divided by tan of alpha. So we have tan alpha, tan beta. So if you substitute that, so what you get is m is equal to AB divided by CB by AB divided by CB dash. So AB cancels. So we just get CB dash divided by CB. Now if you look at the figure, CB dash is nothing but V and CB is nothing but U, right? So in this case, what we'll consider is CB dash as D. So this distance we'll call it as D. And this distance is obviously U. So what we get is m is equal to D divided by U. So this is the magnification produced by a simple microscope. Okay, so what we get is the object and the image, two things we have. The image distance from the center of the lens to the object distance from the center of the lens is the magnification produced by a simple microscope.